How does a shutdown valve works during an ESD trip work in a real industrial system? Start with one mental picture. Energy or information enters. The equipment changes it in a controlled way, and a measurable result leaves. We will follow that path and identify what can prevent it from working. The essential working parts are the safety output, solenoid valve, pneumatic actuator, spring, valve body, and position feedback. Each part has one responsibility. Keeping those responsibilities separate makes the system easier to understand, test, and troubleshoot without confusing a displayed command with the physical condition in the field. When the trip rule is satisfied, the safety output changes state. In this example, the solenoid de-energizes, actuator air vents, and stored spring force drives the shutdown valve closed. The required action can be different in another design. Watch the direction carefully. The next action depends on the previous action completing correctly. Exact settings, fail actions, and timing remain specific to the approved plant design. Electrical logic does not stop flow by itself. The protective action succeeds only when energy is removed or applied as designed and the actuator develops enough force to move the final element within the required safety time. This hidden relationship is the key to understanding why a normal-looking display can coexist with a field problem. Quick check. The logic solver has issued a trip, but the valve remains open. Which part of the safety function has failed to complete its job? The best answer is the final element path, including solenoid, actuator, valve, or mechanical linkage. The question separates the system's main mechanism from nearby equipment that may only display, supervise, or support the action. Low air pressure, a stuck solenoid, excessive packing friction, or a seized valve can prevent full travel. Position switches can indicate movement, but proof testing must confirm the complete trip path. A safe diagnosis compares command, feedback, process response, and local condition instead of trusting one screen or one measurement. Verification should follow the complete path from the initiating signal to the physical result and back through feedback. Record the as-found condition, use approved test points, restore every bypass and isolation, and confirm normal operation before returning the system to service. An ESD shutdown valve turns a logic decision into a physical process change, then reports whether the safe position was reached. Remember the direction of energy or information, the hidden conversion, and the feedback that proves the result. Before field work, follow the plant SOP, PTW, isolation, depressurization, venting, draining, PPE, LODO, approved test procedure, and supervisor instructions.